AC distributors problem 1. A single phase AC distributor XY, which is 200 meter long, is fed from the end X and it is loaded as shown below. So the first load is 50 amperes at 0.8 power factor lagging and 100 meters from point X. Second loading is 100 ampere at 0.707 power factor lagging 200 meters from point X. The total resistance and reactance of the distributor is 0.3 ohm and 0.2 ohm per kilometer. Calculate the total voltage drop in the distributor. The load power factor refers to the voltage at far end. Okay. So in the previous lecture we have seen the derivation for calculating the voltage drop in a distributor, provided the power factor at the loading points is referred to the receiving end voltage. Okay. So for the given distributor we are drawing the diagram. Okay. So a distributor 200 meter long XY is drawn. Okay, and the 200 meter long distributor is fed from end X. So this is the sending end, feeding end, or the sending end. Okay, so there are two loads. First load is 50 ampere 100 meter from point X. So I have taken a point Z at which first load is tapped and it is at 100 meter from X. Okay, so the magnitude of current I have written as 50 amperes and they have written it is 0.8 power factor lagging. So cos phi 1 is 0.8. Okay, then second load 100 ampere at power factor 0.707 200 meter from X. X is the sending end. Okay, so 100 plus 100 200. So we have, that is the receiving end. After 200 meter from X is nothing but the receiving end. So magnitude of current I2 is 100 ampere and the power factor at that load is cos phi 2 is equal to 0.707. Okay, so what we are supposed to calculate? We have to calculate the total voltage drop in the distributor. So the total voltage drop in the distributor is the voltage drop in section XZ plus the voltage drop in section ZY. So we know voltage is nothing but current into impedance. Okay, so you have to calculate the current and impedance of section XZ and the current through and impedance of section ZY. Okay, in the question they had given the resistance and reactance of the distributor are 0.3 ohm and 0.2 ohm per kilometer. Okay, so they had given on per kilometer basis. So coming to this impedance of section is XZ, we know impedance is R plus JX. Okay, impedance of section XZ is equal to impedance per kilometer, which is nothing but 0.3 plus J 0.2. Okay, so coming to the reactance, don't forget to include J parameter, J factor. Okay, so 0.3 R1 plus JX1. Okay, so 0.3 plus J 0.2 into for 100 meters. So for 1 kilometer it is 0.3 plus J 0.2. So for 100 meters is nothing but 0.1 kilometer multiplied by 0.1. Okay, so you will get the impedance of section XZ as 0.03 plus J 0.02 ohm. So in the same way, calculate the impedance for section ZY also. Okay, so impedance of section ZY is 0.3 plus J 0.2 into 0.1 kilometer. Okay, so again for section ZY you will get the impedance as 0.03 plus J 0.02. Okay, so after calculating the impedance, let us calculate the current. So current through section this ZY, current through section ZY is nothing but I2. Okay, so how to write I2? Magnitude of I2 into cos phi 2 minus J sin phi 2 as we have seen in the derivation. Okay, and what is the current through section XZ? It is nothing but the sending end current, which is I1 plus I2. Okay, so now let's calculate the current through both the sections. So current in section, load current at Z, I1 is equal to, so we know the magnitude and power factor separately, we are putting it in complex form. Load current I1 is equal to magnitude of I1 into cos phi 1 minus J sin 1. 50 into cos phi 1 is 0.8. Okay, so from this cos phi 1 is 0.8, phi 1 is cos inverse of 0.8. Okay, you will get some value. Then from that find sine of phi 1. So when you find it, you will get sine of phi 1 as 0.6. So when you multiply, you will get I1 in complex form as 40 minus J30 ampere. In the same way, find out I2 also in complex form. Magnitude of I2 into cos phi 2 minus J sin phi 2. So given cos phi 2 as 0.707. So from that find phi 2, then find sin phi 2. You will get 0.707. So when you multiply with 100, you will get the current in section ZY is I2 is 70.7 minus J 70.7 amperes. Okay. So now we have got the current in section IZY. Now current in section XZ is IXZ is equal to I1 plus I2. Add both I1 and I2. 110.7 minus J 100.7 ampere. So now calculate the voltage drop in section XZ. So voltage drop in section XZ is equal to IXZ into Z. Current into impedance of that particular section. So we have the current and we have the impedance also. So substitute and get the answer. Okay. So in the same way, voltage drop in section ZY. Voltage drop in section ZY is current through ZY into the impedance of ZY. So substitute the current in ZY and the impedance, get the answer. Okay. So now the total voltage drop in the distributor is the drop in XZ section plus the drop in ZY section. Substitute and get the answer.